All right. Example 3. Now, what you're going to write this down before I actually go through it. Now, with it, most people say, Mr. Hall, is that a taco? Ha, 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 ha. And I'm like, no, it's not a taco. So read what the actual problem says, and then you understand what that's supposed to be. Not a taco. Right, so go ahead and stop the video, I'm going to write it down, and then we'll keep moving. The board of directors of Bella, B-E-L-A, Technology Consultants is composed of 10 members. How many different ways can all the members sit at the conference table as shown? So the first thing that's important is understanding, okay, does order matter how we set people up, or does it not matter? And some people are like, well, no, order doesn't matter. Some people say, yeah, it doesn't matter. It does matter. It does. So we just got to figure out which one it is. So it's going to be important that we figure out the right information there. So we know that whenever we do like a seating arrangement in the classroom, let's say I give you guys a brand new seat. If it doesn't matter, like the order doesn't matter how I put you guys, then it means it's not a permutation. But looking at each one of these, if I put people in different spots, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Around this table here, there's 10 people around the conference room table. So let's say we had John here, Peter, Michael, and James. John, Peter, Michael, James. That's one way of putting it. But if we switch it around and we say this is Peter, James, Michael, and John, that's a whole nother seating arrangement. And then if we change it around and say Peter's here, that's a totally different seating arrangement. So however we place these people here, each arrangement is different if we change even just one person. That's a new seating chart for everybody. So if I change like just 2 people in this classroom at 2 seats, that's actually a new seating arrangement. If I change everybody, it's a new seating arrangement. If I only change like the left side of the class, that's a new seating arrangement. If I change the right side. So if I just change one person, it changes the whole order of it, which means order does matter because changing one thing changes the whole thing. It's a whole new seating arrangement. So here, that means permutation, order does matter. And with that, how many people are there? And you can see that from that first line up there. There are 10 people. And how many places are there around the table? There are 10 chairs, 10 spots. Oops. So if there are 10 people and 10 spots, do we use the first permutation or the second type of permutation? We use the first one because they're both the same numbers. So we do P1010, which is 10 factorial. And that should give you about 3,628,800. And again, we did that with factorial. So that's why I was like, it's going to come back to play. So make sure you understand that one. Make sure you remember that. Because that way you didn't have to do as much work. And I just put A up there. That's all it was. All right. And that's it. That's all you have to do for that one. Let's write a sentence out, though. It's always important to write a sentence. So there are 3,628,800 ways for 10 members to sit at the table. And also, again, if something doesn't make sense, like that whole thing of why this is permutation, if it doesn't make sense, call me over. Stop the video and call me over because I can explain it to you maybe a different way that makes sense. But don't just keep going because you're like, I just don't want to listen. Oh my gosh, I'm so bored. So just make sure that you understand why it's that. All right, so let's go to number 2 then. Part B, sorry. Not 2, but part B. So this one says, in how many ways can the elect now can they elect a chairperson, a vice chairperson, treasurer, and secretary, assuming that one person cannot hold more than one office? So we're choosing people like, for example, let's say we're talking about SGA. Now, one person can't get the vice president and be the president, or they can't be the secretary and be the vice president of the senior body or whatever. So with that, because order matters, because we're talking about different places, different things. We're talking about a chairperson, a vice chairperson, a treasurer, and a secretary. Those are 4 distinct different positions, and neither one can have both of them at the same time. That means order matters. So here again, that means we're talking about permutation. So again, if it has something to do with like a position, it talks about a position or talks about a race, like first, second, and third place and stuff of that sort, where order matters, it's a permutation. And again, here we're talking about chairperson, vice chairperson, treasurer, and secretary. Those are 4 different positions that's totally different. A chairperson gets more authority than a vice chair, or a treasurer gets more authority than secretary when it comes to money. So each position is different, so it matters. That order matters. So here we know there are 4. So there are 4 positions there. There are 4 positions. Now, how many people are there in all, though? And that goes back to the beginning at the top of the page. There are 10 members. There are 10 people. So there are 4 positions and 10 people. So that means they're different order, or a different number, sorry. So it means we're dealing with this part here. Sorry. Talking about permutation. And with that, we said the biggest number is going to come first. The biggest number is always in. So it means 10 is in. 4 is R. The biggest number is always first, which is in. And then the second number is always R, the smaller number. So with that, you can either do this part here. 10 factorial over 10 minus 4 factorial. Now, I want to see that whenever we deal with our work here, I want to see that you did that, you set that up. Now, after that, you can put it in a calculator and get an answer or whatever, but that's what we're going to do when it comes to this. I'm not going to show you how to work that out by hand because we don't have time for that. So, with that, we're going to go ahead and you can put that in the calculator. You can do the alpha y equals and then do 10 factorial over 10 minus 4 factorial. So let's do that really quickly too. So alpha y equals gets our fraction. Oops, sorry. Alpha y equals gets our fraction. We do 10 factorial over parentheses 10 minus 4 factorial. And we hit enter. And that gives us 5,040. Okay. Now, I'm going to show you another way of doing this in a calculator, but again, make sure you give me this part here, this fraction, and then I'll get from the answer, I want that part. And again, make sure you write this out in a sentence. All right, so I said that there are 5,040 possible ways for 10 members to have 4 positions. And that's it. That's all we're looking for. All right, later on, I'm going to show you how to put that in the calculator and even find it faster. But just make sure you know how to do it this way.